Okay, this should be our last video for 4.6. It's the third video in the portion of 4.6 where we're taking a graph and we're trying to write the function or the equation for it. So in this case, we have a graph that clearly looks like tangent since it's going from upper right down to lower left. That's sort of standard for tangent. And so our equation, the general equation for tangent would be a tangent bx minus c plus d, and we need to find all these different values, the a, b, c, and d. Now, technically, if you want to be silly about it, you could also say it could be negative equal to negative cotangent x. So that would be kind of like a reflection, but we're not going to do that. We're going to keep it simple, and quite honestly, if it's coming from upper right to lower left, it's going to be tangent. So we need to start finding our things. So the easiest one to find is the midline, right? The midline clearly is the y-axis, so y equals 0 is our midline, and that means that d equals 0, so we're not going to have a d in there. We don't have to worry about d. The next easiest one probably to find would be the period. And remember, the period for tangent and cotangent, the period is pi. Now we look at this one, we go, okay, so the period is when the graph starts repeating itself. It's also sort of the distance from one, kind of think of it as a distance from one asymptote to the other. So here's my asymptotes. So this distance from here to here, that's my period. Okay, and on tangent, typically that's from negative pi over 2 to pi over 2, and then from pi over 2 to 3 pi over 2. Because that's a period, right? I mean a pi between those things. Those were our asymptotes are here, here, here. Another way, though, to figure out the period is to come down here and look at what's the distance between where the graph crosses the midline to where the next part of the next period of the graph crosses the midline. So in other words, if we take this value here and subtract it from the previous value, that gives us this distance, which is our period. All right, so we're going to do that. We're going to come over here, and so for period, I'm actually going to go 3 pi over 4 here minus pi over 4 here. And that equals 2 pi over 4, which equals pi over 2. So for this graph, our period is pi over 2. All right. Now remember, to find the period, if we had the equation and we wanted to figure out what the period is, to do that, we would say take pi and divide it by b. And that's what we're trying to figure out right now. We're trying to figure out if there's a b here. Well, pi divided by b, in this case, equals pi over 2. So we can say that b equals 2. So now we know what our d is. Okay, our d is 0. Our b is 2. And then the last thing we need to kind of do, not last thing, but we need to find our c. Is there a shift at all here? And to find that shift, that phase shift, what we're going to do is we're going to take bx minus c equals pi over 2, since that's where our asymptote normally would be. And we're going to come in here, we're going to put in 0 for x. Oh, I'm sorry, we know what b is. We know b is 2, so 2x minus c equals pi over 2. All right, again, pi over 2 is where normally that asymptote will be. And then we're going to put in 0, because where this, let's see, how to explain, where this equation, the tangent of that, okay, the tangent of I'm trying to think of how to explain this. I'm sorry, this should be, pi over 2. Well, I'm not explaining well. Don't worry about it. Let's just basically to find the phase shift, take what we found here, 2x minus c equals pi over 4. Oh, here, let me just back up for a minute. I want you to be careful, because what you're going to potentially do here is look at this and say, oh, it's shifted, pi over 4. Because normally on the parent function of tangent, it would be coming through 0, and you go, oh, it's shifted pi over 4. And you'd be tempted to put in pi over 4 for C. But we have to take into account that B is 2. So anyway, we come back here to our phase shift. So take what inside the parentheses, but we know that B is 2. And we go 2 times 0 minus C equals pi over 2. So negative C equals pi over 2. So C equals negative pi over 2. All right, so let's take that piece. And we can write out almost our whole equation. So I'm going to come back up to this equation here. And I'm going to go f of x equals, I'm going to still a in here, tangent. Now b is 2, x, and it's minus a negative, so this is going to be minus a negative pi over 2, because c is negative pi over 2. So this is going to be plus pi over 2. And then there's no plus d here. And if you notice, real quick, just if I were to take this here, if I were to take and factor out the 2, it'd leave me with x plus pi over 4. And that's this pi over 4 shift that we see. Okay, but the last thing we need to find here is our A. And our A is our asymptote. And the best way, easiest way to find that asymptote is, let's go in between, let me clean this up a little bit here. Let's go in between our mid, where our graph crosses the midline, and here's my asymptote right here. And I'm going to go halfway between those 2 points, and I'm going to go up here until it hits the graph. And it hits the graph right here, and I come over here, and that value is 1. Okay, so it's and if I came this way, it would be down here, and it'd be 1. So since it's only halfway between where the graph crosses the midline and the asymptote, halfway between, we go up, and where that hits the graph, that gives us sort of our asymptote. And since it's 1, then we don't have to put anything for A. So our final equation for this one is going to be f of x equals tangent of 2x plus pi over 2. That'd be our answer. So hopefully that makes sense. Ask me in class if it doesn't. Okay, let's go down to our last one here. My erase is going really slow for some reason. All right, in this case, it's pretty clear that, again, this is going from upper left down to lower right, and therefore we know that this is going to be cotangent. So f of x equals a cotangent bx minus c plus d. Okay, and let's find all of our different pieces. Again, easiest one here in this case is our midline, and y equals 0. Or in other words, our midline did not shift up or down, so d is going to equal 0. That's 0. And then let's see, our period, again, let's look at what the distance is between, let's go from, okay, so this is 0.25, this is 0.75, so we go 0.75 minus 0.25 equals 0.5, so in other words, it's 1/2. Now, I want you to notice, though, that, or actually we'll find it when we try to solve this. So to find the period, we normally go pi over b, right? So pi over b equals 1/2. So you go, okay, well, that means that if we cross multiply, that means pi equals 1/2 b. So b therefore equals 2 pi. All right, so back up here, our b was just 2, a number. But this time we actually have pi as part of our b. And that, by the way, is why none of these values here have a pi in them. Notice that. Unlike up here where they had pi, Okay, when you see that there's no pi in the values of these different points, then you know that there's going to be a pi in the b. So hopefully that makes sense. And then the last thing is you might think, okay, well, normally, let's see, our asymptotes are, our asymptote is at what, 0 and at 1/2. Here are my asymptotes. And so you might want to sit there and say, well, normally, for cotangent, it normally starts at, it's the center point's at 1/2, at pi over 2, 1/2 pi. And so maybe I have a phase shift here. But because we don't really have a phase shift here, because we've shrunk down our period, there is no phase shift. And then our asymptote, again, to figure out the asymptote, let me clean this off a little bit. Okay. We take that, so we have an asymptote right here. Okay, that's line still there. So we go halfway between where the graph crosses the midline and our asymptote, which is right here, halfway between them, and we go down until we hit the graph. So come down here, and then we hit the graph at 1. Okay, or if we were coming up here, we'd go up here and we hit the graph at 1, and that's halfway in between. So anyway, point being is our asymptote, is 1. So for this equation, it's going to be just simply f of x equals cotangent of 2 pi x. So these are a bit difficult, and I don't know if I did the best in explaining that, but mainly just try to find the key points, and you should be able to do it, and try to make them pretty straightforward.